Good afternoon, everyone.
Happy Teachers Day, sir.
Happy Teachers Day today.
International Teachers
I am national animal. I'm a core follower of RSS. नहीं ऐसा कुछ नहीं. आज इंटरनेशनल टीचर्स डे. थैंक यू. Any doubts? Here is my classical, modern, recent. Halley, ITCZ and jet streams. Mechanism हमेशा पढ़ो in the terms of temperature, pressure, winds में दोनों surface, jet stream and rainfall होने वाला है कि नहीं. Fine. इसमें focus करना on the easterly jet stream, the role of the Tibetan plateau and the western disturbances. Indian Ocean dipole, positive, neutral, negative. Neutral, water flows from Pacific to Indonesia. Indonesia becomes warmer and hence air from here rises, comes and settles over Indian Ocean का eastern part, western part, and ये high pressure से wind will come towards India. Negative, positive, western part is warmer, this part is cooler. Therefore, winds flow from high pressure to low pressure and come towards India. Negative, this part is cooler, this part is warmer, and therefore winds without coming to India, they go towards Indonesia, and therefore Indonesia gets more heavy rainfall. Finlander jet, or Somali jet stream associated with southwest monsoon का rainfall. वो लेके आती है, it brings the southwest monsoon, which then will pick up the moisture and give the heavy rainfall. Clear? If a question comes on western disturbances, I guess you can write western disturbances or winter rain. The only difference is western disturbances will occur only in the North India. This is the region of western disturbances, but winter may rainfall also occurs in the Tamil Nadu coast, and this is due to the northeast monsoon. Northeast monsoon is a wind which blows in India from the retreating monsoon season to the winter season. So northeast monsoon basically is not a season, it is a wind pattern. Fine. If the question comes on the retreating monsoon and October heat, you can easily write. Getting it? Or Southern Oscillation Index. El Nino, La Nina, or the Southern Oscillation Index from the Indian geography point of view, not from the paper 1 point of view, this is from the paper 2 point of view. So we'll first start with the normal condition El Nino and La Nina. Normal condition में लिखने की ज़रूरत नहीं, you already know that the sea surface temperature is higher in the eastern Pacific or western Pacific. कहाँ पे? Normal conditions. Near Australia. And it is cooler. Which current is there? Cold current. Normal में Humboldt current. As a result of this, high pressure कहाँ पे? Normal condition, El Nino. कहाँ पे है high pressure? Peru, Chile coast. Where there is low pressure? Australia. Rainfall कहाँ पे है? Peru, Chile coast. Right? No, it is Australia. And there is a dry conditions in the Peru, Chile coastline. Normal conditions has no influence on Indian monsoon. इसलिए it is not at all important. How will you define El Nino? El Nino, how will you define? What opposite conditions? Why? Why it is caused? Trade winds are always there. El Nino क्यों हो रहा है? Why the El Nino is occurring? What is happening to the trade winds there? Trade winds. Why? Trade winds ही क्या? Stronger, weaker trade winds क्या है? Weakening of the trade winds. What? What? I don't want explanation. Just a key point. Fine. अब कुछ बचा है? What is El Nino Modoki? Modoki. Where are the normal conditions happening? मतलब normal El Nino कहाँ पे होता है? Normal El Nino, the normal El Nino, not Modoki. कहाँ पे हो रहा है El Nino? नीचे नहीं. Which Pacific you will say? Southern Equatorial Pacific or South Central Pacific? When the El Nino like condition happens in the Central Pacific instead of the Peru-Chile coastline, it happens somewhere in the between Australia and Peru. It is known as Modoki. El Nino Modoki. It has more important bearing on the Indian monsoon than the normal El Nino. If the El Nino Modoki is stronger, there is a chances of droughts. Understanding? So दो topics नए हैं. El Nino and Indian monsoon, not the phenomena of El Nino, and El Nino Modoki, La Nina Modoki. Clear? So I am not going to do what is El Nino. Fine? So El Nino, the ENSO index, El Nino Modoki नहीं कर रहे हैं हम. ENSO index has an important bearing on the Indian monsoon. El Nino conditions generally suppresses the monsoon rainfall, while the La Nina conditions generally causes excessive monsoon. Generally causes excessive monsoon. This sea surface anomaly, this sea surface anomaly sea surface anomaly recorded in South Central Eastern Pacific, recorded in South Central Eastern Pacific. Understanding? Why I am using the word central? Northern Pacific, Southern Pacific, Central Pacific. Because it is in the southern hemisphere, South Central. And because it is on the eastern coast, so Eastern Pacific. South Central Eastern Pacific. Between 5 degree north and south of the equator. 5 degree north and 5 degree south of the equator. And from 150 degree east to 90 degree west. क्या है ये? Longitudes. 150 degree east to 90 degree west. What is the longitude of Indian Ocean dipole? Longitude and 90 degree 70 degree west. So 70 degree east या west? East. ये क्यों आ रहा है 150 degree east to 90 degree west? Yeah, it should be 90 degree east. Tell me. बहुत लॉजिकल है. Yes. 180 degree. This is east. This is west. So it is happening in this region. Fine. So 152 degree east to 90 degree west. ये पूरा वाइड रीजन. तो इसलिए यहाँ गलती नहीं है. Is known as what was I saying or telling you? पूरा statement.
The sea surface anomaly recorded in South Central Eastern Pacific between 520 north south of equator and from 150 degree east.
Full stop. Full stop then. Full stop. Long-term correlation. Long-term correlation. Long-term correlation of Indian monsoon and of Indian monsoon rainfall deficit and El Nino is long-term correlation of Indian monsoon rainfall deficit. Rainfall deficit मतलब less rainfall and El Nino is 99%. Is 99%. एक लास्ट स्टेटमेंट मतलब बिफोर वी गो टू एल नीनो ये ब्रैकेट में लिखना. दिस इज अ कंसेप्ट. A strong monsoon is associated with with low pressure and ascent of air, low pressure and the ascent of air at around 25 degree north latitude. ये सेंट्रल इंडिया है या क्या है? 25 degree north पे what is there? This is central India, fine. So strong monsoon is associated at ascent of around at when the air will rise up at 25 degree north latitude. A weak monsoon is associated with ascent of air due to heating near the equator. Near the equator. See, we do very superficially in GS, we don't go into the reasons behind it. What is El Nino, you should know, and weak monsoons hai. Now you understand what is going to happen in El Nino. Air will rise at 25 degree north or air will rise at equator El Nino mein. Air will rise at the equator, because when the air will rise at the equator, air upar jayegi equator se, it is trying to complete an Hadley cell. Remember Hadley cell. So it is going to go to the north, that air. North mein jate it is going to go and descend over the 25 degree north. So what will be over India? Descending air. Descending air, does it give the rainfall? No. Air should ascend to give the rainfall. So monsoon basically is the reversal of Hadley cell. यहाँ पे air instead of rising at the equator will rise over India. And Hadley cell में ऐसे जानी चाहिए winds तो how is Hadley cell? Air will rise from over the equator, fine. Air will go and it will descend here, and then it will start flowing towards the surface as the trade winds. What is exactly monsoon? Opposite condition. Air flows towards India as a southwest monsoon winds. It rises near the India and goes and settles over the Hadley cell. Understanding? This is what the statement means. Getting it? So what is going to happen in El Nino? Air will rise over the equator. In the normal condition, air will descend at the equator. Fine? Sif monsoon mein. Indian climatic region is a different region from all over the world. Getting it? Fine? Monsoon mein, what happens in the monsoon? So, low pressure, pole. So what does high pressure means? High pressure matlab descent of air or rise of air? Descent. See, normal condition means only from the month of June to September. Baki case time, obviously there is a low pressure belt over the equator. इसीलिए तो हमारा क्लाइमेट, हमारा कल्चर, हमारा वे ऑफ लिविंग, our ethics, our values, everything is different from rest of the world. Why? Because neither the wind is following the Hadley cell, jet stream is different, physiography is different, climate is different. That is why India is not known as India, it is known as subcontinent. Britishers used to call it as a subcontinent because India is a continent in itself. Fine? Just I call UP as a nation in itself. UP is not a state. क्या है UP? A nation in itself. Brazil से ज़्यादा population है. Brazil is the 5th most populous country in the world. UP के population is greater than Brazil. 17 crore. Yes. And see the extent of Brazil. UK से बड़ा है Brazil. The only thing is because वो map is using azimuthal projection. Azimuthal projection में हमेशा polar regions are made much bigger. इसलिए UK बड़ा दिखता है. If you use the proper projection, UK should be small dot. So, first normal condition. The El Nino southern oscillation. The El Nino southern oscillation results into formation as well as reversal of Walker cell, During the normal condition, there is a formation of Walker cell. During the El Nino conditions, there is a reversal of Walker cell. So we are not saying कि El Nino results into formation of Walker cell. हम कह रहे हैं El Nino southern oscillation. El Nino southern oscillation means all the conditions in that region. Fine. Next, though Indian monsoon is not directly affected by the Walker cell, though not directly affected by the Walker cell, but monsoon circulation is latitudinal. Monsoon circulation is latitudinal, while Walker cell is longitudinal. Is the Walker cell longitudinal? Yes. Peru, Chile, latitudes वही है to Australia. This is what is longitudinal, right? Walker cell. Indian monsoon is equator to the tropics, latitudinal. Hence, the changes in the Walker circulation affects the latitudinal Hadley cell, Normally, the air ascending from the Indian subcontinent during the summers, is forced to descend in the Indian Ocean, Therefore, the surface winds blow from the equatorial part of Indian Ocean, picking up moisture picking up moisture. And giving rainfall over India. Giving rainfall over India. Giving rainfall over India. Fine. Quick diagram जो हमने already किया था. Giving rainfall over India. See, to show the three-dimensional effect, you will have to make a slanting block box. Understanding this? El Nino Southern Oscillation. यहाँ पे लो प्रेशर, उस साइड हाई प्रेशर. इंडोनेशिया ऑस्ट्रेलिया रीजन पे देयर इज अ लो प्रेशर. क्लियर विद दिस? Anticyclone over Tibet. लग रहा है एक लॉन्गिट्यूडनल एक लैटिट्यूडनल. कैन यू मेक इट आउट इन द डायग्राम? What? What is? MGO is on the ocean. Madden-Julian oscillation is from India to Pacific. Monsoon is from India to equator. How is Madden-Julian oscillation? How is this? What is this diagram? This diagram is nothing but this diagram. It rises from the Tibetan plateau, goes and settles over the Mascarenes high and comes back as a Somali jet or Somali current. Understanding the difference? How is Madden-Julian oscillation? Where it is going and settling? Pacific. Where is monsoon? Monsoon is only the phenomenon of Indian Ocean. It has nothing to do over the Pacific. This is monsoon. Is anything to do with the Pacific? It is only to do with the Indian Ocean. The same diagram you have drawn. How will you draw MGO here if you want to draw? This will be MGO. Fine with the diagram? Can I continue? हो गया सबका? El Nino conditions. El Nino conditions. The warm episodes of ENSO. The warm episodes of ENSO is associated with the shift in the Walker cell. Episode ENSO is associated with the shift in the Walker cell. Associated with the shift in the Walker cell. With the air descending over the Australia, with the air descending over the Australia Indonesia region, the air descending near the Australia Indonesia region, it causes the air masses, to move towards the equator, where this air masses, or where this air move towards the equator, full stop, ज़्यादा लंबा statement आपको confuse करेगा. The air which moves towards the equator, gets heated and ascends कहाँ पे हो रही है air ascends? Over the what I said here is, during the El Nino circulation there is a low pressure here, so यहाँ से air is rising upwards. देखो हमने क्या लिखा है, then this air goes from the Australia Indonesia region, it starts descending, resulting into formation of high pressure. इस साइड आएगी तो वॉकर सेल उल्टा हो गया, शिफ्ट इन द वॉकर सेल, बट एयर डिसेंड होने के बाद वो इस साइड भी आएगी, एंड दिस एयर विल स्टार्ट असेंडिंग नियर द इक्वेटोरियल रीजन्स ऑफ द इंडियन ओशन. चलो, आई विल एक्सप्लेन यू फर्स्ट एंड देन आई विल डिक्टेट यू. This is Africa, Indian Ocean, Indonesia, Australia region, South America. During the normal circulation, there is a high pressure here. So the air will come down, it will flow from east to west, and after going towards the Australia, Indonesia, it will rise up. This air, after rising upwards, will get bifurcated into two parts. एक complete करेगा Walker cell, fine. दूसरा आएगा and it will descend over the equator. But जो air descend कर रहा है over the equator, then it will start flowing towards India as the southwest monsoon winds. Understanding? If you remember, I had already told you. Now just try to correlate these two maps. एक 3 dimension में, एक top view and एक side view. So air is descending over Australia, it is flowing towards this region, Australia, Indonesia, and यहाँ से it is rising upwards. In the normal condition क्या होता? This was a high pressure, this was a low pressure. So the air would have been rising from here, going towards the Australia, Indonesia, shifting here, completing this, we would have called this as a Walker cell. The air which was descending, the air would have descended, it would have come here and then come back, and we would have called this as a Walker cell. अब air जो ऊपर जाएगा, due to the tropospheric lead, it will get bifurcated into two parts. वो जाएगा and it will come and descend at this part, creating a high pressure here. That means high pressure somewhere here. This is the equator. And in the Indian Ocean, Somali jet will drive this high pressure towards India as the southwest monsoon winds. Getting it? You will have to correlate. थोड़ा दिमाग सोचना पड़ेगा. You will have to imagine what is happening. Everyone clear? क्या हो रहा है? Understanding? अब during the El Nino, understood? During the El Nino, Walker cell उल्टा हो गया. It has become red in color. So the air is descending over here, and then air is flowing towards here, ऐसे आ रही है, and यहाँ पे it is ascending. यहाँ पे then it is low pressure. And when the air is ascending here, it will get bifurcated into two parts. We are not concerned about वो जाके descend करेगी over India, and India will result into high pressure. Monsoon means high pressure or low pressure over India? Low pressure. High pressure कहाँ होना चाहिए? Equator. इसलिए जो मैंने concept आपको पढ़ाया, अब समझो इस concept. Good monsoon means ascent of air around 25 degree north latitude. यहाँ पे low pressure होना चाहिए. Bad monsoon means rise of the air near the equator. So during the El Nino, what is happening? Air is rising near the equator. And if you remember the first class of monsoon, Sunday को जो हुआ था, उसमें this was told to you. If there is a high pressure here, means if there is a descent of air, then good monsoon over India. If there is no high pressure over here, then bad monsoon. Understood? Easy है El Nino. The only thing is you have to imagine. समझ में आया सबको? Got it? Fine. So what was I dictating? Equatorial region of the Indian Ocean. Full stop. When the air ascends over the equatorial regions, ascend near the equatorial regions of Indian Ocean, ascends near the equatorial regions of Indian Ocean. When the air ascends near the equatorial regions, when the air ascends near the equatorial regions, this ascending air mass will descend over India, thus weakening the Somali jet stream, Understanding the relation? Weakening the Somali jet stream. Somali jet stream is trying to go up from India. El Nino circulation is trying to descend over India. So weakening the Somali jet stream and thus reducing the rainfall over India. Rainfall over India. You can draw this diagram. नीचे का डायग्राम ड्रॉ करने की जरूरत नहीं. So what is happening during the, have you finished drawing that diagram? Imagine, ये सिर्फ कंसेप्ट के लिए है मैप. इमेजिन द ग्रीन कलर का लाइन्स आर सोमाली जेट स्ट्रीम. कैन आई टेक इट अबव? Imagine the green color lines are Somali jet stream. It is bringing good monsoon over India. During the El Nino year, यहाँ पे होगा low pressure, यहाँ पे होगा यहाँ पे होगा high pressure, and यहाँ पे होगा low pressure. So the air will descend over here, rise from here. This rising air will come and descend over here. And after descending over here, it will go back to its Walker cell circulation. But this air will also flow towards Indian Ocean. Air को क्या फर्क पड़ता है whether it is Indian Ocean or Pacific Ocean? Air is air. It is going to flow from one place to another. जहाँ पे it is going to descend, it is going to flow. This air will rise from here, and after rising, it will flow towards India. And it will try to descend over India. किसको रोक रहा है वो? Somali jet stream को, green line को. And as a result of this, rainfall is weaker. कल मैंने कहा था Indian Ocean dipole is unrelated event to El Nino. Understanding? What is Indian Ocean dipole? This part of Indian Ocean becomes very, very warm. And इसलिए the Somali jet stream will become more moist, more stronger, more hotter, less denser. Fine? So जितना ज़्यादा this region of Arabian Sea will become warm. This is the region जहाँ पे Somali jet stream is originating. Wind Somali jet stream will come with high speed towards India because of the warm Arabian Sea. कब पता चला था Indian Ocean dipole? In 1997. What was the 1997 strongest El Nino year ever recorded, fine, in the modern climatology. And surprisingly good monsoon over India. Why? You will understand. That is why I have taken this diagram. This region of the Arabian Sea becomes warmer. This is a high pressure. Somali jet will start coming when there is a positive Indian Ocean dipole with great speed. It will come towards India, and आने के बाद, even if the El Nino is suppressing it, depend करता है किसकी strength ज़्यादा है. So during the positive Indian Ocean dipole, किसकी strength ज़्यादा है? Somali jet stream पे वो El Nino के effect को खत्म कर देगा. वो rise होगा ऊपर. It will complete a Madagascar high का cell, और एक बार Madagascar high का cell complete हो गया तो कोई फर्क नहीं पड़ता. Then El Nino कोई फर्क ही नहीं पड़ता. Right? So this is how it is related. Now understood the concepts? Clear? Ask me very properly, don't be shy, because you will not find this on the net. It took me 4 years to understand this. That is why I am telling you. Understood the concept? ये छोटा concept समझने के लिए 4 साल लगे. अच्छा हुआ तब क्वेश्चन नहीं आया, अब क्वेश्चन आ सकते हैं. See, I come from an era जब cell phone was a luxury, laptop was a luxury, net was a luxury, and जब ये चीज़ें थी तो answers भी average थे. अब everyone has this issue, so your competition can write better answers. And UPSC is all about competition. अगर आपके competition ने below average answer लिखे तो average answer is first ranker. If your competition writes above average answer, then the best answer has to be first ranker. Getting it? It's all about competition. कैसे क्वेश्चंस आते थे करंट अफेयर्स के नाम पे? अरेंज द फॉलोइंग टेनिस टूर्नामेंट्स फ्रॉम जनवरी टू दिसंबर. ये थे हमारे टाइम के कुछ कुछ क्वेश्चंस. फाइन. यूएस ओपन, फ्रेंच ओपन. ऐसे नहीं था कि जीएसटी का कलेक्शन अंडे में है या शुगर में है या ऐसा, कभी नहीं था. क्लियर? क्लियर विद दिस? बिकॉज इट इज ऑल डिपेंड किसकी ताकत ज्यादा है. सोमाली जेट स्ट्रीम कहता है पॉजिटिव इंडियन ओशन डाइपोल है, मैं ज्यादा, मेरे पास ज्यादा गर्मी है. फाइन. आई हैव मोर हीट एनर्जी, आई कैन डिस्प्लेस अल नीनो. बाकी के समय जब नॉर्मल कंडीशंस है, अल नीनो पूछता है कहाँ गया तेरा डाइपोल, आई विल सप्रेस यू बिकॉज आई हैव मोर पावर. इट इज ऑल द दिस थिंग. फाइन. So याद रखना, at the equator for good monsoons to occur in India, at the equator there should be which pressure? High pressure, not low pressure. High pressure कब होगा? When winds will start rising from here, not when the winds starts descending from here. Clear? And when the winds will start rising from here, we will call it as but before I proceed, both El Nino and Indian Ocean dipole, both El Nino, Indian Ocean dipole are unrelated events, are unrelated events unrelated events and the strength of the Indian monsoon is determined by both ENSO as well as Equino. Both ENSO as well as Equino. This is just for your understanding. Table ऐसे बहुत सारे factors हैं which IMD has to check. El Nino क्या है, Equino क्या है, means Indian Ocean dipole क्या है. Then they will see, yes, there can be good monsoon if the positive Indian Ocean dipole is there, and Pacific में there are normal conditions. There will be drought if both of them are adverse. That is, if there is a Indian Ocean में negative Indian Ocean dipole, as well as in El Nino there are El Nino conditions. There will be normal rain in case there is a, or there will be slightly less than normal rain but drought नहीं होगा. if there is a positive Indian Ocean dipole in spite of El Nino. That is the year 1997. Year 2013 will be the worst because positive Indian Ocean dipole as well as La Nina. Getting it? जीएस का आंसर लिखते समय कोई ज़रूरत नहीं, बट ऑप्शनल के आंसर में देयर शुड बी अ मेंशन ऑफ सोमाली जेट, जैसे वी हैव मेंशनड इन मोस्ट ऑफ द पॉइंट्स जहां जहां चांस मिला. Can I continue? The La Nina is associated with extremely strong Walker cell extremely strong Walker cell which causes greater amount of air to rise over Indonesia Australia region, greater amount of air to rise over the Indonesia Australia region, due to stronger upwelling of cold denser water, along Peru-Chile coast, stronger Walker cell is associated with more air descending in the equatorial regions, of Indian Ocean, strengthening the Findlander, or Somali jet stream, which is associated with, full stop के बाद, this is associated with one, more rainfalls over India, and second, more cyclonic activity. Second, more cyclonic activity in the Bay of Bengal region. More cyclonic activity in the Bay of Bengal region. More cyclonic activity in the Bay of Bengal region. पीछे का डायग्राम की कोई ज़रूरत नहीं है. But this is what is happening in the oceans during the La Nina. We have drawn a simple diagram at the top. This is a somewhat three-dimensional view. सोमाली जेट स्ट्रीम और ज़्यादा स्ट्रांग हो जाती है, जितनी नॉर्मल कंडीशंस है उससे ज़्यादा स्ट्रांग हो जाती है. Continue, done with this. Take 2 minutes to look at what we have done before we can progress. नहीं तो confusion बढ़ेगा. What is this? El Nino, La Nina? देखो फिर से. What is this diagram? Where is the low pressure? Indonesia, Australia. So, what is this? El Nino. कैसे ला लेना? El Nino is a phenomenon of Pacific. So you have to just look at Pacific. Yes. El Nino is not a phenomenon of Indian Ocean. Pacific region में what is there? There is low pressure over Indonesia, Australia. मतलब high pressure over South America. So क्या है ये? तो फिर ये क्या है? There is a high pressure over Peru, Chile and low pressure over Australia. What is this? What is this diagram? This is a normal phenomenon. मैं जानबूझ के कर रहा था. To just look at your confidence level. If I make one more line and जितना ज़्यादा हवा यहाँ से उठाऊंगा उतना more high pressure over India, then you will call this as El Nino. और इस डायग्राम को अगर मैं चेंज करता हूँ then it will result into, if I change the diagram like this, कि there is a low pressure over this region and then there is a high pressure over here which results into so we will call this as El Nino. Fine. Understand one thing. It is affecting the Somali jet stream. Why? Because it is settling over India. अब मैं इस पूरे लाइन को, सपोज आई एम अ कंट्रोलर ऑफ El Nino, मैं इस पूरे El Nino के फिनोमेना को थोड़ा ईस्ट में शिफ्ट कर देता हूँ. सो दिस डिसेंट विच इज ऑकरिंग ओवर इंडिया विल ऑकर समवेयर ओवर इंडोनेशिया, मलेशिया. अंडरस्टैंडिंग? नाउ सपोज why there is less rainfall over India? Because air is descending during the El Nino over India. Understand very very properly. And now see, suppose यहाँ से air is coming towards equator, air is ascending from here and instead of descending near India it is descending near Malaysia. Even if it is an El Nino year, कोई फर्क पड़ेगा Indian monsoon पे? Indian monsoon is affected because air starts descending over India, which weakens the Somali jet stream. But if the air does not descend over India, during the El Nino, will it affect Indian monsoon? Understanding what I am saying, everyone? Understanding? Suppose due to some conditions, imagine the high pressure is formed here, air from here rises, there is a low pressure here during the El Nino condition, air from here rises in the equatorial Indian Ocean, it goes and it descends over India. Fine? But due to certain conditions, imagine you are a magician and due to certain conditions, you are creating a low pressure here, air from here is rising and it is descending over Malaysia. So it is not descending over India. So India में Somali jet stream आएगी, it will rise up, mascarin is high, अपना चलता रहेगा, El Nino अपना बाजू में चलता रहेगा, जो करना है. Understanding this? Example. Understanding what has happened this year? 2019. 2019 is a El Nino year, but El Nino came in late April, May. Generally El Nino should come in the month of Jan, December, Jan. चला गया था वो, ऐसा लगा था El Nino like conditions आएंगे, न्यूज़पेपर में आया था, went away. El Nino became very strong. See, El Nino का intensity also matters. ऐसा नहीं कि weak El Nino is going to affect India. because that is happening in the Pacific Ocean. There is a certain kind of intensity. It resurfaced again in the month of April and became very strong in the month of May. Getting it? So 2019 May, El Nino year was there, but still it did not affect the monsoon. And where the air will rise, where the air will settle, kyu hoga, this is not in human hands. So next point of our answer is, continue writing and tell me whether you have understood the point once I finish dictation. Sea surface temperature Pacific में गर्म हुआ तो El Nino is nothing to do with Indian Ocean. Pacific. कब आएगा El Nino? जब सदर्न हेमिस्फीयर में समर्स है. कब होंगे सदर्न हेमिस्फीयर में समर्स? ड्यूरिंग दिसंबर, जैन, फेब. सो कहाँ पे आएगा El Nino? साउथ अमेरिका कोस्ट. मॉनसून का अफेक्ट करेगा. कब आता है मॉनसून? जून में. सो गवर्नमेंट ऑफ इंडिया लुक्स कि यहाँ पे El Nino डेवलप हुआ कि नहीं, एंड देन कि में शायद मॉनसून स्ट्रांग हो सकता है, शायद मॉनसून नहीं हो सकता. सो इसलिए बजट उस हिसाब से बनता है. अंडरस्टैंडिंग? हम प्रेडिक्ट नहीं करते El Nino. El Nino डेवलप्स, हमें पता चल जाता है 6 महीने पहले कि वेदर देयर इज El Nino और नॉट. El Nino because it comes in the month of December, Jan, and Indian monsoon जिसको affect करता है comes in the month of June. Therefore, we already know beforehand whether it is El Nino year or not. So what is the government going to do in the month of December? Pollution को तो fight करना है in India, but एक नज़र रहेगी whether the sea surface temperature is rising in Pacific or not, whether the El Nino like conditions are developing or not. If it is developing, then it will be challenging, because then agriculture उस हिसाब से बजट में एग्रीकल्चर बजट, ड्रॉट मैनेजमेंट सब रेडी रखना पड़ेगा, सब्सिडीज. चैलेंजेस ऑफ गवर्नेंस इन 21st सेंचुरी, ये सब है. क्लाइमेट चेंज का ये चैलेंज है. अंडरस्टैंडिंग? दिस इज द चैलेंजेस टू गवर्नेंस इन 21st सेंचुरी. Next point. Not all El Nino events, not all El Nino events cause drought in the Indian subcontinent. Not all El Nino events cause drought in the Indian subcontinent. Because along with the Indian Ocean dipole, there are two other important factors of El Nino. There are two other important factors of El Nino. One, location of warming in Pacific. Location of warming in Pacific. Location of warming in Pacific. Now, take this down and tell me whether you have understood. वही मैंने आपको समझाया था. If the location of the warming occurs, if the location of the warming is such that sinking sinking of Walker cell, sinking of Walker cell does not occur around Indonesia. Sinking of Walker cell does not occur around Indonesia. ये अल नीनो ईयर के समय. सो वॉकर सेल कहाँ पे सिंक होता है? इंडोनेशिया के पास, राइट? सिंकिंग ऑफ द वॉकर सेल डज नॉट ऑकर अराउंड इंडोनेशिया, बट इन द वेस्टर्न पैसिफिक, then Indian monsoon is not affected. Then in the Indian monsoon is not affected. Or in simple words, if the warming shifts to, if the warming of the Pacific, El Nino is the warming of the Pacific. कौन सा पैसिफिक वार्म हो रहा है? जो कूल है. मतलब कौन सा कूल था? हम्बोल्ट करंट वाला रीजन. If the warming of the Pacific shifts to far eastern Pacific, far eastern Pacific, far eastern Pacific, then Indian monsoon is not affected. Then the Indian monsoon is not affected. Can you understand this diagram? Indian monsoon is not affected. फार ईस्टर्न, ओनली पेरू चिली कोस्ट के आसपास वाला रीजन वार्म हुआ तो वहाँ से थोड़ा बहुत एयर विल राइज एंड इट विल कम एंड सिंक नियर ऑस्ट्रेलिया, नॉट नियर इंडोनेशिया. सो कोई फर्क नहीं पड़ेगा बिकॉज ऑस्ट्रेलिया इज देयर. बट दिस इज व्हाट इज द नॉर्मल वार्मिंग ऑफ द एल नीनो. ब्लू कलर इज द कूलिंग एंड ये है एल नीनो का वार्मिंग. सो कितना ज़्यादा एल नीनो वार्म हो, कितना ज़्यादा पैसिफिक वार्म हुआ है. इट इज़ नॉट जस्ट कि यही पार्ट ऑफ पैसिफिक वार्म होता है. ड्यूरिंग द नॉर्मल एल नीनो दिस एंटायर रीजन बिकम्स वार्मर एंड देयरफॉर लो प्रेशर. लो प्रेशर से इट बिकम्स हाई प्रेशर हियर इंडोनेशिया, ऑस्ट्रेलिया. देन इट कम्स बैक. द इंडियन ओशन ऑल्सो रिजल्ट्स इनटू इंडियन ओशन एंड वॉकर सेल. यहाँ पे आते आते बिकॉज इट इज फ्लोइंग इन द इक्वेटोरियल रीजन वो गर्म होता है, फिर वो ऊपर जाता है. ऊपर जाके इट विल कम एंड सेटल ओवर इंडिया. गेटिंग इट? नेक्स्ट, second, there are several other factors. There are several other factors such as equino मतलब इंडियन ओशन डाइपोल, Indian Ocean dipole, which in the positive phase can give the rainfall even in the presence of El Nino. Even in the presence of El Nino. Second, मतलब second point का first point equinox, second sub point heating of the Tibetan plateau, If the Tibetan plateau is extremely heated, then अल नीनो may not affect. अभी तक ये रिलेशनशिप एस्टेब्लिश नहीं है. अल नीनो may not affect. अल नीनो may not affect. Fine, this is a wrong diagram, but what I wanted to tell you is, थोड़ा ये इंफॉर्मेशन गलत दी है इस डायग्राम में. फिलीपींस का कोई लेना देना नहीं है अल नीनो से. But 1997 में only the eastern part of the Pacific has become warmer, not इतना पूरा रीजन. So कहाँ पे शिफ्ट हो गया अल नीनो का सेल? फार ईस्ट में. So इसलिए air is rising from here, it is giving the rainfall, it is not reaching Indonesia, Australia region, it is coming and settling near Philippines, and इसलिए Philippines has become drier. That is the location. So last जो point है far eastern Pacific, first point का last point, remember this for prelims also. Okay, if the El Nino develops in the far eastern Pacific, it will not affect India. Now you tell me, if the El Nino develops in the central Pacific, will it affect India or not? जितना दूर होता है उतना इंडिया को अफेक्ट नहीं करेगा. जितना यहाँ पे सेंट्रल पैसिफिक में डेवलप होता है, इंस्टेड ऑफ, सो इट विल राइज फ्रॉम हियर, इट विल कम एंड सेटल ओवर दिस रीजन. मतलब मैडागास्कर हाई नहीं बनेगा. अंडरस्टैंडिंग? इट विल सेटल ओवर दिस रीजन. गेटिंग योर? इट विल राइज फ्रॉम हियर, ट्रैवल दिस डिस्टेंस, इंडोनेशिया के बदले यहाँ सेटल होगा वो. फिर एयर ऐसे जाएगी, एयर जाके मैडागास्कर हाई के बदले लो होगा. मैडागास्कर एयर विल राइज अप. सो दिस अल नीनो विच डेवलप्स इन द सेंट्रल पैसिफिक is what is known as El Nino Modo Key. Getting it? चलो ये पॉइंट समझ में आया. सी द सैटेलाइट इमेज, नासा का ही सैटेलाइट इमेज. जून 1997 का एल नीनो ज़्यादा स्प्रेड नहीं हुआ है, वो साउथ अमेरिका के आसपास है. 2015 का एल नीनो कितना स्प्रेड हुआ है? रेड कलर इज दिस थिंग. नाइनटीन 1997 ओनली ये पार्ट गर्म था. 2015 ये पूरा गर्म था. So therefore 2015 is one of the worst drought periods of India. 2015 drought था. Now बस ये सबसे डिफिकल्ट टॉपिक है क्लाइमेट का, इसके बाद कुछ नहीं है क्लाइमेट. El Nino, it is warmer here, it is rising low pressure, it is going and settling over Indonesia, Australia. La Nina, it is colder here, it is going and rising over this thing, Pacific Ocean. Modoki, central part is warmer, so it is rising from the central part, it is going towards this region, it is settling over यूएसए रीजन एंड इट इज सेटलिंग ओवर इंडिया. सो इंडिया के ऊपर क्या है? हाई प्रेशर. जितना आप सेंटर में शिफ्ट हो गए, जितना आप यू विल शिफ्ट फ्रॉम ईस्ट टू वेस्ट ऑफ पैसिफिक, उतना यू आर कमिंग नियरर टू विच कंट्री? इंडिया. अंडरस्टैंडिंग? सो अल नीनो मोडोकी विल रिजल्ट इनटू वेरी हेवी रेनफॉल्स, सॉरी ड्रॉट्स, वेरी स्ट्रॉन्गर ड्रॉट्स ओवर इंडिया. क्या फर्क है दोनों में? ईस्टर्न पैसिफिक इज वार्मर, यहाँ पे सेंट्रल पैसिफिक इज वार्मर. ईस्टर्न पैसिफिक इज कूलर, सेंट्रल पैसिफिक इज कूलर. ला नीना मोडोकी. गेटिंग इट? So El Nino Modoki, you see, Peru Chile coast nahi hai warm. Where it is warm? Somewhere in the central of the Pacific Ocean. So it is rising upwards, it is coming, it is settling here. Then it is going and settling ऐसे जा रहा है and it is going upwards. कहाँ पे? वहीं से जहाँ से Somali jet stream originate हो रहा है. Right? Getting it? It is going and low pressure. Somali jet stream के लिए there has to be high pressure. But what is there during the El Nino Modoki? There is a low pressure. This is the region जहाँ पे Somali jet stream is originating. Getting it? Clear? बस 5 मिनट, इसके बाद things are very normal again. This is the worst thing. ये क्यों वार्म हो रहा है? इसका रीज़न एक ही है, ग्लोबल वार्मिंग, ह्यूमन इंटरेस्ट. क्योंकि ये सबसे पहले देखा गया था इन 2012 एंड देयर इज नो एक्सप्लेनेशन कि ये क्यों वार्म हो रहा है. सो साइंटिस्ट आर सेइंग कि इसका रीज़न इज ग्लोबल वार्मिंग. जीएस में कहाँ पे इतना बताऊंगा मैं? अभी भी जीएस में बताऊंगा कोई इफेक्ट नहीं पड़ता. इतना थोड़ी बताऊंगा मैं जीएस में. जीएस में इनको पढ़ाया मैंने अल नीनो ड्रॉट्स, बस इतना याद कर रहा हूँ. अल नीनो मोडोकी मैं बोला याद करो, सेम लाइक अल नीनो. तुम्हें क्या पढ़ाया जीएस में? अल नीनो मोडोकी पढ़ाया? नहीं, सिर्फ सेंट्रल पैसिफिक में हो रहा है, बस इतना याद रखो. ये थोड़ी मेंस में आने वाला है जीएस में. मेंस में अगर ये आता है जीएस में तो ज्योग्राफी ऑप्शनल वाले लिख पाएंगे, उनको भी तो कुछ फायदा मिलना चाहिए जीएस. There has to be, now this is a perfect diagram. इसका resolution is better. Understanding? El Nino and El Nino Modoki. This is the satellite image. Getting it? कहाँ पे गरम? El Nino. कहाँ पे गरम? Fine. So air from here rises up, comes, settles. It flows as a surface wind. As a surface wind, यहाँ से it will start rising up. So we are not concerned about that. जहाँ पे Somali jet stream है, वहाँ पे it will start rising up. Fine. You forget about El Nino Modoki. Last year, some student asked me about Somali jet stream in GS in the June batch only. I told him कि ऐसा कुछ concept ही नहीं है. It is for African monsoon, not for Indian monsoon. Because then GS will never end. And students will be wasting their time in reading what is not required. El Nino Modoki came in GS only in 2012 because that was the year it was discovered properly. बस 2012 में है question in prelims regarding El Nino Modoki. And last year was El Nino Modoki year. So warming of eastern Pacific, far eastern Pacific, no effect. Warming of central Pacific will be having effect. So when the central Pacific becomes warm, it is known as Modoki. Modoki means central in वहाँ के tribal languages में. Understanding Hawaiian language etc. So El Nino Modoki. It is seen that if the warming of the central Pacific, it is seen that warming of the central Pacific has greater effect. Warming of the central Pacific has greater effect on the Indian monsoons. Warming of the central Pacific has a greater effect on the Indian or Asian monsoons. This anomalous warming, of central Pacific, वो था ईस्टर्न पैसिफिक, सदर्न हेमिस्फीयर में, ये है सेंट्रल पैसिफिक इन द इक्वेटोरियल रीजन्स, in the equatorial regions, surrounded by cold waters to the east and west, surrounded by cold waters to the east and the west. Is known as El Nino Modoki. मोडोकी का मीनिंग है सिमिलर, सिमिलर टू El Nino. While the normal El Nino is associated with the warming of eastern equatorial Pacific, is associated with the warming of eastern equatorial Pacific, and the cooling of western Pacific, Modoki is warming of central Pacific. Similarly, when the anomalous cooling of the central Pacific takes place, similarly when the anomalous cooling of central Pacific takes place, it is known as La Nina Modoki. It is known as La Nina Modoki. Both El Nino Modoki and the La Nina Modoki both the El Nino Modoki and the La Nina Modoki are believed to be are due to anthropogenic warming of the oceans, are due to the anthropogenic warming of the oceans, are due to the anthropogenic warming of the oceans. I guess I have already told you they have greater impact on Indian monsoon because center में है. Fine. पहले डायग्राम और फिर हम एक लास्ट लाइन लिखेंगे. It should be thermocline, not thermohaline. In fact, during La Nina Modoki, can you see पेरू चिली में भी रेनफॉल होगा. लो प्रेशर है, सबसे हमें लेना देना. I hope you are understanding what is this cold layer. That is a cold layer, thermocline layer. इनका हैंडआउट आ गया. मनु हैंडआउट आ गया. नहीं नहीं आ गया है क्या, आने वाला है. तूने वो लोगो डाल दिया, बता दूं एटलीस्ट. मैं किसी को रख रहा हूँ, कोई है जान पहचान वाला जो ज्योग्राफी ऑप्शन संभाले? There. So you go inside. One last line. During the El Nino Modoki, the Somali jet stream and the mascarin is high. The Somali jet stream and the mascarin is high. Both become weak. While during the La Nina Modoki, they become extremely stronger. They become extremely stronger. La Nina Modoki, they become extremely stronger. During La Nina Modoki, they become extremely strong. Modoki, they become extremely strong. वही अपोजिट ही होगा अल नीनो के, they become extremely strong. Fine. So आगे लिखने की ज़रूरत नहीं. अब एक लास्ट मैडन-जूलियन ऑसिलेशन. ऑब्वियसली ये सब सेपरेट क्वेश्चंस आएंगे, ये मॉनसून में इतना बड़ा क्वेश्चन नहीं आएगा, ये मैडन-जूलियन ऑसिलेशन पे सेपरेट आएगा. यू हैव टू राइट इट रिगार्डिंग द मॉनसून. सो मैडन-जूलियन ऑसिलेशन, व्हाट इज मैडन-जूलियन ऑसिलेशन? हैव आई टोल्ड यू मैडन-जूलियन ऑसिलेशन in this class? Have I told you? So Madden-Julian oscillation is nothing but a new phenomena that has been observed. Unlike El Nino, which is totally associated with the sea, Indian Ocean dipole associated with the sea, Tibetan plateau associated with the land, एक नया phenomena है, and again the knowledge is limited. Maybe it is an outcome of that. It is ocean, atmosphere, land के coupled phenomena. That is, it is affects both ocean, land, and obviously evaporation will keep on changing. Therefore, it is known as an atmosphere also phenomena. Now, it has two phases. One is the convective phase. Convective phase means the air will rise upwards, and one is the regression phase, means the air will descend. Now, अगर मैडन-जूलियन ऑसिलेशन का कन्वेक्टिव फेज इफ इट डेवलप्स ओवर इंडिया, तो क्या होगा? एयर विल राइज अप. सो मतलब लो प्रेशर विल बिकम मोर स्ट्रॉन्गर. देयरफॉर द रेनफॉल्स विल बी मोर or less? More. So there will be more rainfalls in the Madden-Julian oscillation. Generally Madden-Julian oscillation का ये फर्क है from El Nino, La Nina, Indian Ocean dipole. El Nino, La Nina पूरे साल के लिए रहते हैं. Madden-Julian oscillation remains for 20 to 60 days. 20 दिन के लिए रहेगा, चला जाएगा, और it may remain for 2 months, चला जाएगा. Fine. So it is said that this retreating monsoon, which has become very, very strong, is due to convective phase of Madden-Julian oscillation which has developed over India. And therefore, India is still under the low pressure region. And since the India is still under the low pressure belt, air is rising upwards. Right? So that is why I had shown you this diagram. But how it is different from the Africa? Madagascar high, Mascarenes high, alag. Indian Ocean dipole alag. El Nino, La Nina alag. अब El Nino, La Nina इधर है. Indian Ocean dipole इधर है. सोमाली जेट स्ट्रीम तेज ऐसे है, लैटिट्यूडनल है, बाकी सारे लॉन्गिट्यूडनल है. दिस इज ऑल्सो लॉन्गिट्यूडनल, बट फर्क ये है कि इट इज बिटवीन इंडियन ओशन एंड विच ओशन? पैसिफिक ओशन. गेटिंग इट? सो एयर राइजेस अपवर्ड्स एंड देयरफॉर क्या है इंडिया में? हेवी रेनफॉल. एयर विल गो एंड सेटल ओवर पैसिफिक. सो सेंट्रल पैसिफिक में देयर आर ड्राई कंडीशंस, बट नोबडी बॉदर्स अबाउट दिस बिकॉज यहाँ पे यू कैन सी देयर इज नो वन हु इज स्टेइंग. It is totally an ocean surface. Just an easy thing. आपको यही लिखना है. What is a Madden-Julian oscillation? Clear? नहीं? क्यों हो रहा है? Don't worry. अभी तक किसी को नहीं पता क्यों हो रहा है. ये पूरे रीजन में, ये पूरे रीजन में, ना इंडिया ना इंडोनेशिया. दिस इज फ्रॉम द हॉर्न ऑफ अफ्रीका. यहाँ पे कहीं तो इंडिया है एंड दिस इज इंडोनेशिया. ये पूरे रीजन में लो प्रेशर है. गेटिंग? Madden-Julian oscillation. It is a major fluctuation in the tropical weather. It is a major fluctuation in the tropical weather. It is a major fluctuation in the tropical weather. Either on the monthly, weekly time scales, monthly or weekly time scales. Discovered by Madden and Julian. इसलिए Madden-Julian oscillation दो साइंटिस्ट के नाम है. Next, it is an ocean atmosphere coupled phenomena. It is an ocean atmosphere coupled phenomena. Next point, it is caused due to variations. देखो ये local variation के कारण है, इसलिए ये छोटा है. It is caused due to variations in wind, sea surface temperature, cloudiness, and causes variations in the rainfall. Cloud अगर ज़्यादा है तो insolation कम है, therefore there will be less convection and causes changes in the rainfall. Next point, it has two phases. Subpoint 1, convective phase, in which air rises upwards causing very heavy rainfall, in which air rises upwards causing very heavy rainfall. And sub point 2, suppressed phase, in which the wind settles, causing dry, causing stability and dryness in the atmosphere, causing stability and the dryness in the atmosphere, causing stability and dryness in the atmosphere. Next, Madden-Julian oscillation, Madden-Julian oscillation moves from west to east. Madden-Julian oscillation moves from west to east. Madden-Julian oscillation moves from west to east. Moves from west to east. If India experiences a convective phase, it will cause greater precipitation during the Indian monsoon. While during the suppressed phase, the precipitation will decrease. During the suppressed phase, the precipitation will decrease. Madden-Julian oscillation is limited only to the tropical regions of the world. Madden-Julian oscillation is limited only to the tropical regions of the world. Is limited only to the tropical regions of the world. GS के लिए सिर्फ ये लाइन, what is known as सो अभी कल ही IMD ने डिक्लेयर किया कि द ईयर 2019 वाज न्यूट्रल अल नीनो, positive Indian Ocean dipole and frequent MJO events. So क्या था? अल नीनो का कोई फर्क नहीं पड़ने वाला था because it was in the neutral phase. Neutral phase अल नीनो means normal conditions. Positive Indian Ocean dipole. Somali jet stream was very strong and therefore and also जब मैडन-जुलियन oscillation आया तब ज़्यादा रेनफॉल हुआ. केरला फ्लड्स, पूना फ्लड्स, मुंबई फ्लड्स. Stronger positive Indian Ocean dipole, stronger Somali jet. Stronger Somali jet explains Bihar floods. Understanding? Because it will go and it is striking Bihar also, it is striking west coast also. It is known as eastward moving pulse of clouds. ये पूरा क्लाउड ऐसे ईस्ट की तरफ जाएगा, इसलिए ईस्टवर्ड मूविंग पल्स ऑफ क्लाउड्स. यस, ग्रेटर हीटिंग ऑफ टिबेटियन प्लेट, राइट. So this is, we have completed all the aspects of Indian monsoon. Paper 1B, paper 2B. Getting it? मैडन-जुलियन ऑसिलेशन मुझे नहीं लगता इतना इम्पोर्टेंट है, यूपीएससी पूछेगी, बट जितने भी करंट अफेयर्स के मैगजीन है, जितने भी टेस्ट सीरीज है, उन्होंने क्वेश्चन पूछा है, इसलिए मैं दे रहा हूँ. कैन आई रब दिस?
The Madden-Julian Oscillation, or MJO, is an important climate driver of tropical weather around the globe. While the El Niño Southern Oscillation and the Indian Ocean dipole drive changes in Australia's climate on seasonal to annual timescales, the MJO can change the odds of a wetter or drier period on weekly to monthly timescales. So what is the MJO? It is an eastward moving zone of wind and cloud that circles the tropical areas of the globe in around 30 to 60 days. When that extra cloud arrives, it can increase the chance of receiving above average rainfall.
See, obviously this is from Australia point of view.
However, ahead and behind the extra tropical cloudiness are regions where it might be drier than usual. The relationship between the MJO and Australian weather patterns changes with the season. Its greatest effect on our rainfall occurs during the northern Australian wet season, which runs from October to April. During this period, the MJO can influence the timing, variability and strength of the Australian monsoon. Late in every year, a belt of low pressure known as the monsoon trough forms in the tropics and becomes the focus for enhanced cloud and rainfall for the season. The monsoon is at its most active when the trough is close to or over northern Australia and typically brings widespread.
Can you understand shifting of the ITCZ?
Rainfall to tropical areas. When the MJO is in the Australian region, it can strengthen the monsoon trough and bring even more rainfall. And at the start of the season, it can encourage the monsoon trough to form. The monsoon trough can also go through periods when it is weaker, Australia, it can bring higher pressure systems and less cloud, causing this break. Another way that the MJO affects our weather is its influence on tropical cyclones. During the tropical cyclone season, cyclones are more likely to develop when the MJO is nearby. They are less likely to develop when it is further away from Australia. The MJO also has a relationship with the El Niño Southern Oscillation, which swings between La Niña, neutral, and El Niño. An MJO can bring periods of weaker trade winds over the Pacific. These can help trigger or strengthen El Niño, potentially bringing less rainfall for eastern Australia. Likewise, it can weaken or disrupt La Niña, a climate driver often associated with above average Australian rainfall. While the MJO has its biggest impact on the tropics, this is not the only region it can affect. In the southern winter and spring, the dry season in northern Australia, the tropical cloudiness of the MJO shifts north of the equator, but it can still influence rainfall across parts of central and even southern Australia due to the changes it can trigger in weather patterns. The Madden-Julian Oscillation plays an important role in driving Australia's climate. As with all our climate drivers, no two MJO events and no two set of impacts are exactly the same. Understanding this key Australian climate driver can help you better understand Australia's highly variable climate is influenced by the broad patterns in the oceans around it and the atmosphere above it. We call these patterns our climate drivers. The most significant climate driver in the Indian Ocean is the Indian Ocean Dipole, often called the IOD. The IOD refers to the year-to-year changes of tropical sea temperatures in the western and eastern Indian Ocean. These changes can alter the weather patterns that affect Australia's rainfall. The IOD varies between three phases: positive, neutral, and negative. On average, each phase occurs about every 3 to 5 years. Positive or negative IOD phases usually begin in autumn or winter and return to neutral around the end of spring when the northern Australian monsoon arrives. During a neutral phase, water from the Pacific flows between the islands of Indonesia, keeping seas to Australia's northwest warm. Air rises above this area and falls over the western half of the basin, blowing westerly winds along the equator. Temperatures are close to normal across the tropical Indian Ocean, and the IOD has little influence on our climate. During a negative phase, westerly winds intensify, allowing warmer waters to concentrate near Australia. These stronger winds also mean it's harder for cool water to rise up from the deep near Indonesia. As these warmer waters move east, the cloud
उनके लिए नेगेटिव फेज, अपने लिए इट इज also negative phase. It is a negative phase. Right? Can you see it is more colder? This is more warmer.
clouds follow, favouring weather patterns that ultimately bring rain to southern Australia. A positive IOD phase has the reverse temperature pattern in the Indian Ocean and the opposite effect on Australia's climate. The westerly winds weaken and sometimes easterly winds form, allowing warm water to shift towards Africa. South of Indonesia, these changes in the winds allow cool water to rise up from the ocean depths. With cooler waters and descending air in the eastern Indian Ocean, less cloud forms. This changes the path of weather systems coming from Australia's west, often meaning less rain over central and southeast areas. Often, but not always, a positive IOD coincides with the drying influence of the El Niño in the Pacific, both drawing rainfall away from Australia. For southeast Australia, this can cause the failure of critical winter-spring rains.
हमारा कोई इसका फर्क नहीं
Final
पड़ता.
land of severe summer fire seasons. For instance, 1982, the driest year on record for the region, was both a positive IOD and El Niño, and was followed by the devastating Ash Wednesday bushfires. Likewise, a negative IOD can often occur during La Niña, both pushing more rain towards Australia's climate. No two Indian Ocean dipole events and no two set of impacts are exactly the same. Understanding this key Australian climate Australia's highly variable climate is influenced by the broad patterns in the oceans around it and the atmosphere above it. Some of these patterns are not only more obvious than others, but also predictable. We call these our climate drivers. One of our strongest climate drivers is the El Niño Southern Oscillation, or ENSO. ENSO is a natural cycle in Pacific Ocean temperatures, winds, and cloud. This influences climate right around the globe. In Australia, ENSO is often behind our climate extremes, from devastating floods to searing droughts. ENSO naturally swings between three key phases: La Nina, neutral, and El Nino. A typical ENSO phase starts in the first half of the year and lasts until the following autumn. Sometimes we can get the same phase for 2 or more years in a row. On average, it takes about 4 years to swing from El Nino to La Nina and back again. So what are these ENSO phases, and how do they impact Australia's climate? Well, during the neutral phase, steady trade winds blow across the tropical Pacific from the east to west. These winds pile up warm water in the western Pacific. In contrast, water temperatures to the east are lower as the trade winds cause cool water to be drawn up from the deep. The temperature difference across the tropical Pacific Ocean causes air to rise to Australia's north and descend near South America. This creates a huge connected cycle called the Walker circulation. We consider neutral to be the normal phase because we're in this state more than half of the time. While a neutral phase may bring more normal weather to Australia, droughts and floods are certainly still possible. When we move into a La Nina, it's a bit like the neutral phase has gone into overdrive. The trade winds blow harder, expanding the warm pool on the Australian side of the tropical Pacific and cooling the oceans towards South America. This increases the east to west temperature difference and makes the Walker circulation even stronger, and the trade winds blow even harder again. This is called a feedback loop, and once it starts, we're locked into a La Nina until at least the following autumn. With the higher ocean temperatures, we get greater evaporation, more cloud, and more rain in the western Pacific. For Australia, this means a higher risk of widespread flooding, lower daytime temperatures, and more tropical cyclones. On the other end of the scale, we have El Nino, which is almost the direct opposite of La Nina. During El Nino, the trade winds actually weaken or reverse, allowing warmer waters to drift back towards the east. The change in the ocean temperature patterns mean the Walker circulation breaks down, resulting in even weaker trade winds and even more warming in the east. Once this feedback starts, El Nino has set in. With the warm water shifting east, the evaporation, cloud, and rain follows, shifting away from Australia. That means a greater risk of drought for northern and eastern Australia, higher temperatures and more heat waves, clearer nights and a longer frost season, and fewer tropical cyclones. While there are scientific definitions for El Nino and La Nina, in reality, no two events and no two sets of impacts are exactly the same. We also know some impacts will emerge as an ENSO event is developing. And
Clear with all the concepts? Unfortunately, IMD कोई ऐसा वीडियो नहीं बनाता, that's why we look at two videos, Bureau of Australian Meteorology and Bureau of UK का meteorology. Clear? Understanding why we are making diagrams like this? Because that is the international way of making the diagrams. So, What will be the effect of global warming on Indian monsoon? Your assignment. चलो पढ़ के आए हो या खुद ही बोल रहे हो? Have you studied or? I'll give you some points. So, सबसे पहले point is what is monsoon circulation? It is nothing but land, air, moisture का है this. So during the global warming मैं अभी कुछ बताऊंगा नहीं, मतलब I will not dictate. During the global, why the global warming? Because greenhouse gases are going to trap the heat. Fine? And because they trap the heat, temperature contrast, just try to understand, don't write anything. Temperature contrast, that is, kuch region should be low pressure, kuch region should be high pressure. But due to the trapping of heat, this high pressure, low pressure ka balance is not established. And since this high pressure, low pressure ka balance is not established, the rainfall does not occur or the monsoons will become weak. Understanding? ये एक impact हो सकता है. Second impact of the global warming is scattering of incoming solar radiations. Why? Because of aerosols. Global warming, remember, is associated with greenhouse gas emissions. Global warming is associated with industries and vehicular emissions, and uske साथ साथ uska cousin is pollution. Pollution means aerosols. Aerosols means more scattering. More scattering means more which light? Yellow light or blue light? More blue light, and blue light is cooler, and more scattering results into less heating of the land, and less heating of the land is causing, that is, it is nothing but cooling, and therefore again decrease in the rainfall. Understanding? Why the decrease in the rainfall? Due to scattering. Optional का आंसर ऐसे होना चाहिए, scattering, absorption. It has to be technical. It is not कि हर global warming GS में ice caps are melting, glaciers are melting, Tibetan plateau is increasing. No. Fine. Third, global warming and agriculture. More agriculture versus more forest. Understand this. More agriculture, more albedo. More forest, more absorption. That is less albedo. So more of an agriculture, there is more albedo, and therefore there is again more cooling effect of the land. As a result, low pressure is weaker on India, and hence the monsoons will become weaker. Understanding? Getting it? More warming means more event like ENSO positive, means Al Nino or Al Nino Modoki, and therefore weak monsoons over India. But it may also result into intense but short duration convective rainfall over India because of heating of the land during the summer season. So what will increase? Total rainfall will increase over India, but this rainfall will come in the form of or thunderstorm. और हमेशा ऐसी rainfall is dangerous and useless. Why? Ground cannot take so much amount of water in such less period. आज भी सोचो फिर से on the global warming. We'll meet on Monday. Getting it? Yes. We'll start with jet streams. And obviously, one point which he said is also true, that less ice over Tibetan plateau may increase the rainfall. But revise whatever we have done, because monsoons फिर भूल जाओगे.